Hi, this is 2023 IBHL paper 1 and time zone 2. So the first question is, what is the mass of one molecule of carbon 60? So there is a formula, like we have to know, like mass is equal to number of atoms of carbon times mR of carbon divided by Avogadro's constant. So how many numbers of atoms there? There are 60 times mR of carbon is 12.01. You can see from periodic table which is given, and divided by 6.02 times 0 times 10 to the power 23. So that's the way. When you calculate it, it becomes 1.2 times 10 to the power negative 21 mass. That's the mass. That's the way to solve this question. Next is, there is a gas A react with a gas B to produce AXBY. Now there are 20 cubic centimeter of A react with 20 of B to form 10 of AB. But 10 cubic centimeter of A is excess. That means only 10A is used with 20. What is meant by 10 and 20? Like 2 moles of B and 1 mole of A, it form 1 mole of AXBY. So that means it should form A1 and B2, because 2 moles of B there. So there must be the X value would be 1 and B value would be 2. So D is the answer. Next. Now the volume of V fixed for a fixed mass of an ideal gas was measured at constant temperature and different pressure P. So we have to make the graph relationship between PV and pressure. So for example, K is constant, which is equals to 1. Now P is inversely proportional to volume. And when we put the constant, P is equal to K divided by V. So K is equal to PV. So K constant. So that means PV is not going to change. It stays the constant. If you are increasing the pressure, so there is no change in PV, because that's the constant. That is equals to constant. That's why A is the answer. What is the correct ground state electronic configuration? So straight away these are wrong. Why? Because in the same orbital, electron always paired with the opposite spin, and in same degenerate orbital, electron filled with same spin unpaired. This is the lowest energy state spin. That's why A is the answer. That's the wrong thing. Successive ionization energy graph. You have 3 ionization energy graph, then there is a huge gap. That means there is the shifting of shell. That's what you need to know. That means there are 3 electrons in outer shell. After that, there are shifting of shell. In sodium, there is 1 electron in outer shell. In magnesium, there are 2. In aluminium, there are 3 electrons. So after 3 electrons, there is a huge gap. That's why the answer is aluminium. Okay. So next question is, which sequence of oxides arrange in order of increasing acidity? Acidity mean non-metallic oxide, because metal oxide, they are base, and non-metal oxide, they are acid, and aluminium oxide is amphoteric. So oxides arrange in increasing acidity. So sulfur trioxide is acidic, which is more acidic than aluminum oxide than sodium oxide. Which property increase down the group? So down the group, always remember atomic radius is going to increase. Melting point of alkali metal, they are going to decrease. Why? Because the intermolecular strength of metallic bonding is going to decrease, because the metallic bonding strength is going to decrease. That's why. So it's not going to increase, that wrong. Reactivity, as we move from top to bottom, the electron become further away from the nucleus. So that's why we can say that the reactivity is going to increase, right? Always remember, down the group for the metals, reactivity increases, since outer electron remove easily. That's why 1 and 3 is the right answer. Which of these factors explain why NiCl4 minus and have different colors? If you look, chlorine has -4 overall. Overall charge is equal to -2, so nickel plus, it has +2 charge. In cobalt, again -4, resultant equals to -2, so cobalt also has +2 charge. So they have different colors. How do we know? Because they are transition metal. Ligand is not the thing which actually identify the color. Charge is not the thing which identify the color. Spectrochemical series is not the thing, but the metal. If the metal is transition, they both are transition metals. Their outer electrons present in d orbital, and all those elements which has incomplete d orbital, they do have colors. Incomplete d orbital. So that's why. Which of the compound has incomplete octet? That's so easy question. Like incomplete octet, we can say that boron. If you see the boron has electron like this. It has 3 electrons in outer shell and it share only 3. So it is still, after sharing the electron, still it is electron pair deficient. That's why it involved in dative bond. What is the correct sequence of compounds arranged in increasing boiling point? So basically, the boiling point depends on the strength of intermolecular force. There are 3 forces: hydrogen bonding, dipole-dipole, and London force. So that's the strongest force. And all those compounds which has H bonding, they has highest boiling point. So the alcohol has the highest boiling point, right? Then we have to see the aldehyde. It has the dipole-dipole force. Aldehyde, this one is alcohol. So number 1, number 2 strength, and number 3 the last one, the dipole-dipole. So that's why the ketone, ether has the lowest boiling point. These are ether has lowest. So the highest one is for the hydrogen bonding, then dipole-dipole, then ether. So B is the answer. What is the correct comparison of the bond angle? Now you know what? Ammonia. Ammonia has a lone pair. According to valence shell electron pair repulsion theory, due to lone pair, the angle should be 107.5 degree. In the case of ammonium ion, the lone pair is going to make a dative bond. So now it become the AB4 with no lone pair. The angle now become 109.5 degree. Whereas the NH2, there are hydrogens and there are now one lone pair and another lone pair because it has extra electron. Now it has two lone pair. It has two lone pair. Now angle, it should be 104.5 degree, just like the water. So that's why we can say that the highest angle is 109.5, then ammonia, then NH2. What is the valid preferred Lewis structure of NO2? You know what? You have to see the structure first. The Lewis structure. Now you have to make the a double bond between nitrogen and then, like, you know what, it has one unpaired electron. It should be on, like, the nitrogen. This oxygen has a lone pair, and that's the radical. So that is the preferred Lewis structure, because nitrogen has to make 3 bonds. So that's wrong. That's wrong. You have to choose one of them. So there is always the unpaired electron on nitrogen, because the nitrogen is the thing which is basically share this electron with oxygen. So radical always form, we have to withdraw the electron, like in the case of HNO2, that's NO2, the radical is the derivative from this. So hydrogen electron shared with this nitrogen, and when we remove hydrogen, because oxygen is not the thing that we remove, so that's why we can say that the unpaired electron should be on nitrogen, because the NO dot is the radical which actually anything it combined with nitrogen, not with oxygen. That's why the dot should be on nitrogen instead of oxygen. That's why C is the answer. Which wavelength and energy of the light will break bond in ozone rather than oxygen? You know what? Higher energy is not the option. Why? Because higher energy, it may break the oxygen molecule. So we need lower energy, because ozone is already very unstable. It is already very unstable. So we need lower energy. And always remember, like, lower energy and the longer wavelength, because energy and wavelength, they are inverse. So longer the wavelength, that's the energy. That's why C is the answer. Now the enthalpy of formation of ammonia is negative 46 kilojoule per mole with respect to 1 mole. So what is the energy for this reaction if there are 2 moles? So negative 46 times 2, it become negative 92. So 92 is the answer. Okay. So when 100 cubic centimeter of 1 mole HCl is mixed with 100 cubic centimeter of 1 mole of NaOH, the temperature of resulting solution is increased by 5 degrees Celsius. Okay. what will be the temperature change when 50 cubic centimeter of 2 moles. So we have 1 volume of HCl 0.1 decimeter cube. So if we see the HCl concentration, that is like 1 mole per dm cube, plus volume of sodium hydroxide required is also 0.1 dm cube, and concentration of sodium hydroxide required is again 1 mole per dm cube. So it will give us the 0.1 mole. If we calculate the mole, it will give us 0.1 mole. That's the first situation. In the second situation, the volume of HCl is 0.05 and HCl concentration is 2 molar and volume of HCl is again 0.5, volume of sodium hydroxide, and concentration of sodium hydroxide is 2 molar. So it will give the moles 0.1, moles 0.1. So moles are same. That means if we the delta H value, like what will be the temperature change in degrees Celsius when 50 of, since we have the same moles, so initially it increased by 5 degrees Celsius. So when we change this, so again like the 5 degrees Celsius delta H, because we have the same moles, so that's why we can say that it should be overall, it should be 10, right? Because you just doubles the concentration, that's why. Which of these change involve in increase in entropy? What is entropy? Entropy is randomness or disorderness. So lithium solid to gas is what we can say that it's disordered. And molecule to atom is what? Disordered. So that's why D is the answer. What is the correct? Delta H negative T, delta S 0. You know what? Delta G is equal to delta H minus T delta S. So when delta G is equal to 0, that means reaction is at equilibrium. So that's why we can say that C is the answer. Okay. So curve X . So which change would produce curve Y? Now curve Y rate is slow. That means we can't use catalyst because catalyst can't increase the volume. So catalyst is not the option. If we increase the concentration, the graph should be increased like this. That's why this is not that's wrong. So we just increase concentration 0.1. So that's why we can say that B is the answer. Okay. Which two colliding species have the highest probability of having the proper orientation? You know what orientation mean, like when the reaction is going to take place easily. So molecule is not the option. So the answer should be from A and B, highest probability of having proper orientation. Now those atoms which are like more similar, with similar molecules, with similar shape, with similar geometry, they have same geometry, that's why A is the answer. Which process proposed mechanism for the following reaction is consistent with the rate law? You know, for the rate law, slow step determine the rate, so you have to cancel all the fast step. So for slow step, you have to see in the rate law thing, do you have this thing? So you have to see fluorine F2. So F2 is there. F2 is there. F2 is there. And NO is there. So that's why the slow step should be this. Step 1. We have to see the slow step actually. So that's the slow step and that is the answer. Which value increase when temperature of the reaction increase? You know, activation energy when it is low, then the rate, and temperature when the temperature of reaction increase. So temperature is not linked with activation energy. Temperature is not, because activation energy change by catalyst. That's why A is wrong. Rate constant, enthalpy of reaction. Enthalpy is delta H. So delta H is change in energy. Change in energy. So energy change is not linked with the enthalpy, like with the temperature, and equilibrium constant also is not having the link with the temperature. So rate constant is the thing which actually having the effect with the temperature. Change, yeah, by changing temperature. So which condition would cause the given equilibrium to shift to the right side? So yeah, very good question. So basically we can say that like when the react product is going to withdraw, it shifts the equilibrium to right side. So that's why A is the answer. Water is not in the equilibrium. Solid NaCl is not in the equilibrium because we need aqueous chloride ions which shift the equilibrium to forward. That's why. And system subjected to increased pressure, the pressure is applicable only for the gaseous reaction. That's why A is the answer. Okay, which value of equilibrium constant K and the Gibbs free energy favor the reverse reaction? Okay, so delta G is equal to RT ln K. If you lower the K value, so delta G become positive. If you higher the K value, So delta G become negative. So that's why the positive value, it shifts the equilibrium, reverse reaction. And also you need to know the delta G positive, because positive delta G mean reaction should be spontaneous, because negative delta G mean reaction is not going to take negative delta G mean reaction is going to take place, and positive delta G mean forward reaction is not going to happen, so that's why it favors on reverse reaction. So that's why C is the answer. What is the order of increasing conductivity for the aqueous solution? That's a very good question. So you know, Ka is inversely proportional to pKa, and Ka is when higher, then strength of acid is higher, then it dissociate quickly, it conduct quickly. So that's the entire sequence. So highest pKa, you have to check lowest pKa, because lowest pKa has the highest Ka value, 1, 2 and 3. So that's why we can say that methylamine should has the highest, then phenylamine, then ethanol. So B is the answer. Which graph represent the pH curve? Weak base. So base part is weak, titrated with strong acid. Look at this, the volume of acid. So base is weak, so line is not like straight. This could be the option and this could be the option. So C and A is straight away wrong. And acid is strong, so acid is like this. Acid should be having the straight line, so that's why we can say that B is the answer, because acid is straight there and acid is strong. What condition result in buffer solution? So buffer is of the weak acid, it is not of strong acid. So weak acid and its conjugated salt, which is a strong base. So that's why D is the answer. Now question 27, that's very tricky question. The ionic product of the water is Kw is 3 into 10 to the power negative 15 at 10 and 5 into 10 to the power negative 13 at 98. What is the true about hydrogen and hydroxide and concentration when pH 7 of this condition? So for the first one, Kw is equal to 3 into 10 to the power negative 15 which is equals to hydrogen ion and hydroxide ion at pH is equal to 7. So Kw value is given, that is 3 into 10 is power negative 15 is equal to hydrogen ions, which is 10 is power negative 7, and hydroxide ion concentration we have to find. So after solving it, hydroxide concentration would be 3 into 10 is power negative 8, and if we solve the second, in which Kw is equal to 5 into 10 is power negative 13. So again, Kw, which is 5 into 10 is power negative 13, is equal to hydrogen ion into hydroxide ion. So 5 into 10 is power negative 13 is equal to, again hydrogen ion is 10 is power negative 7 divided by 10 is power negative 7 is equal to hydroxide. So hydroxide ion value would be 5 into 10 is power negative 6. So you can see the OH value. Would it be they are greater or lesser? You can easily see. So the above case, hydrogen ion is higher than hydroxide ion. In this case, hydrogen ion is less than hydroxide ion. So that's why, what is the answer? The answer should be D. That's the solution of this question. Which species oxidizing agent? We can see manganese convert from 2 plus to 5 plus there. So manganese is get oxidized, and if you see bismuth, -6 overall charge equals to -1, so bismuth has +5 charge, so +5 to +3, so that's why bismuth oxide itself reduce. So this is oxidizing agent. So in this case the oxidizing agent is bismuth oxide. Which chemical process involve would produce a voltaic cell? That's so easy. Spontaneous redox reaction, because it produces electricity. It produces a spontaneous redox reaction. It produces E cell positive. What combination of the voltage is correct regarding the reduction oxidation of stranded hydrogen? So always remember, for the stranded hydrogen equation, 2H plus aqueous plus 2 electron arrow H2, and its E potential is 0.0 volt. So oxidation and reduction both are 0. So this is the answer. Which will eventually yield the greatest mass of deposit copper in the electrolysis of copper sulfate? So always remember, deposited copper anode should be there, not zinc, not inert, copper anode, and inert cathode, because where the copper is going to deposit. That's why A is the answer. Which compound is aromatic? First of all, you need to know aromatic mean benzene, and this is not benzene. Benzene has a complete ring, no additional thing present in the ring. So that's why B and A is the answer. So this is not ester, because ester is this linkage COOC. That's why B is the answer. Which reaction mechanism involve heterolytic? Hetero mean ions formed. So electrophilic addition, heterolytic is formed, electrophilic substitution, nucleophilic substitution, all of them heterolytic fission is occur. So homolytic occurs in nucleophilic substitution. So there is a mechanism called nucleophilic substitution. So nucleophilic substitution reaction is the reaction in which we can say that sorry, nucleophilic free radical substitution. Free radical substitution. So in free radical substitution, homolytic fission occurs. What is the IUPAC name? The periodicity of the OH is higher, so 1, 2, 3, 4. At second and third carbon there is methyl group, so 2,3-dimethyl. 2,3-dimethyl. Butane 2-ol, at second carbon there is alcohol, so that's why B is the answer. Is that clear? So what is the correct order of reaction? So halogenoalkane is turns into alcohol, that is substitution. Alcohol get oxidized, that is oxidation, because alcohol turns into carboxylic. Carboxylic turns into aldehyde, that is reduction. That's why A is the answer. Observed specific optical rotation of a compound is 7. What is the specific optical rotation of a racemate of this compound? Racemate, basically they do not have like specific, they are inert, and when the optical activity is equal, it is racemate. They cancelled out each other. So that's why we can say that yeah, so it should be 0 because it has 0 optical activity. That's why. Which mechanism does nitration? Yeah, that's easy. Electrophilic substitution. Which observation would explain systematic error for the experiment involving combustion of magnesium to find? So yeah, systematic error is crucible had black soot. That is systematic error. System has some error. Which technique is best for determining bond length? X-ray is the technique which determining bond length, because mass spec determine MR, infrared spectroscopy determine functional group, and this identify the structure. So X-ray. The following graph shows the concentration of C4H9Cl versus time. So what's the average rate? So yeah, change with respect to time. So that's what like you have to calculate to get the answer. Change with respect to time. So B is the answer.
Thank you for staying with me to the end. Don't hesitate to leave your question or request in the comment section. I'll see you guys next time.